Okay, we better move on to the next part of the program, and that is with Dr. Sam Markell. Sam will be providing an overview of disease management in dry bean.
All right, so I want to give you updates on 4 different things: rust, bacterial blights, white mold, and SCN. And I'll tell you right away, we've got a little data on rust, fungicides, some of the newer products that I'll share with you. Bacterial blights, we don't have a lot of updates, but I think it's very important to keep these in front of you, especially with short seed supply. I'm going to take you to an area in the Carrington website to give you some updates about white mold, and then just a quick update on soybean cyst nematode, and I will show you the new maps. So as I go through these, I'm going to talk about the conditions that favor the diseases first, what they look like and how they develop, because I think that's very important for determining how and when and if to manage them. So to begin with, one of the things that I always would recommend is that you carry something with you to help you identify diseases in the field. Some of them are fairly simple, but white mold is pretty easy to identify, but some of them are a little bit more tricky. And so this is a high quality material publication that we put together. It's pocket size. You can find these online, and there are some physical copies available as well. Okay, so let's start with rust. Rust is something I'm concerned about, particularly if it's warm and dry. And to illustrate this a little bit, we have a sunflower leaf in front of you, and the sunflower rust only goes to sunflower, and dry bean rust only goes to dry beans. But the conditions that rust needs are the same. And so this leaf was a sunflower leaf in a field that was flat. It was facing the sky, and there's a little depression, you can see by the shadow in that image, where water pooled. And so the dew period was just a little bit longer in that leaf. And you can see that's where the rust developed. So the main thing here is that rust does not need rainstorms. It doesn't need thunderstorms. It really just needs leaf wetness. So when you have heavy dews, fog, early canopy closure in any crop where you can get a rust, that's going to favor it. And it usually rusts like warm temperatures. And that is absolutely true for dry bean rust. Dry bean rust is very important to scout for, and just as a reminder, it looks a little different when you scout early in the season. So I would recommend when the canopy's closed, usually sometime around the 4th of July or a little later, take a look. And rust starts in dry beans in hot spots, and they're tough to see. It's not like cereal wheat rust or something that shows up almost everywhere at the same time. So I have an image here of a hot spot that I took a few years back, and I'm just walking towards that hot spot. And as they get closer, you can start to see it, but you really have to get into that hot spot and start grabbing leaves from the middle of it. And in the middle of the canopy is where it's most favorable because you have longer dew periods. And if I'm scouting for rust the first time, I almost always go to a shelter belt because you have a little less wind, maybe a little more dew, a little less light early in the morning, and that's where you usually see it first. Rust can do quite a bit of damage. This is a picture from a few years ago near the Devil's Lake area, and that rust was kind of eating some of that lunch up there. It was pretty powerful. Okay, so with rotation can help. Genetic resistance is really good when it works, but rust has multiple races, and a lot of the varieties are not resistant. That's changing, but slowly. Fungicides are important, and fungicides are very effective on rust, which is something that is not necessarily the case for some of the other diseases we work with. So with fungicides, timing is really important. So you don't need a preventative spray for rust. Scouting, and then if you find it, putting a fungicide on after is usually good enough to catch it, as long as there's not an epidemic and progress, a lot of damage. And then by the time pintos would start to stripe, fungicides are no longer valuable. Typically, I get most concerned about rust when you see it in July. It is usually a week or two after a rain event where we know the ground is wet. We know there's going to be a lot of dew. And there's lots of fungicides that can work on rust. So here's an example from 2020. So this was just this year. We're looking at some of the newer products. The way you would read this is you have rust severity across the bottom. So the bigger the bars, the more disease. And then you've got the rates and the products on the left. The non-treated control is NTC, and that's the bar in yellow. So that's the one that just had an epidemic. The rust severity is good. It's not super high, but it's definitely good enough to separate the products. And I should have mentioned in the bottom here that this was all put on about a week after we observed rust in the field. It was all 8002 T-Jet flat fans, 20 gallons per acre and 40 PSI. So you can see that in general, most of these products are working pretty good. The letters of significance follow the bars. And in general, what we have seen in the past is that triazoles and strobilurins tend to work the best, and a lot of these are combination products that contain one of those. Now, we have a lot of variability in our trials, and the rust pressure wasn't extremely high, so there is no yield differences here. This was a 2018 trial, very, very similar, a few more products, some single action products as well. You can see that non-treated control in yellow again. Rust severity again wasn't super high, but good enough to separate the products. I would point out that if the same letter follows the bars, they're not statistically different. So the non-treated control, Endura, Serenade, Thompson, Propulse, they're all statistically the same, but you can see quite a few on the bottom that are not, where rust is being managed pretty good. And we've got data from many years that basically shows very similar results. So we have a lot of good products out there. This is yield data, and we had a lot of damage from other things in this trial. And I will admit that many of you on today's call, maybe all of you, grow better dry beans than I do by looking at that yield. Okay, switching to bacterial blights. So bacterial blights are quite a lot different than rust, and one of the most important things about bacterial blights is they can be transmitted by the seed, which is one of the primary reasons we recommend good seed. If you have a little bit of bacterial blight and you plant it in a field, as soon as it starts raining, you'll start to see that disease show up. So clean seed is really critical. Certified seed is very important. Bacteria really needs thunderstorms, and they need some damage on the tissue to start that infection process. So unlike some of the other fungal diseases, bacteria, they need wounding, they need tissue wounding to get in there. So thunderstorms, hail, high winds, sandblasting, anything that wounds those plants when it's wet can start that epidemic. This is common blight. When you start to see it, you usually see these necrotic areas of a leaf, often on a margin, and sometimes there's a halo, sometimes there's not. It is most severe usually on the edge of a field where you might have more damage, and then it will quickly spread in. Bacteria will reproduce on any of that green tissue if it's wet, and so this is a pod, and you can see that bacterial oozing on the pod tissue. And so whenever you have wetness, you should imagine that you have some of this ooze. So anytime you have more damage to those tissues, anytime you're moving through a field with equipment when it's wet and damaging tissues, if you have this ooze, you will be spreading that bacteria around through the field. Eventually in the season, it'll start to look like this, and it can go into the seed, of course, and then the cycle can repeat if that seed is in the ground. So unfortunately, we don't have a lot of options once bacterial blight starts to show up. We've been doing research that North Harvest has been a part of for several years, and this is results from a 2016-2017 trial, and you can find this report in the North Harvest Bean Growers magazine. Essentially what you're looking at here is 3 different locations where we have different bacterial blight severity, and we're looking at foliar control of this. The non-treated is on top, and if you follow with me, we have Fargo, Prosper, and Oaks, and so very different conditions. You have very high levels of severity in some of these, only 40-some% in Fargo, but over 90% in Prosper. The average severity is on the very end. And there are some products that will help reduce severity, and there is a trend towards yield. However, it is difficult to show yield differences with an application of some of these products. And I can tell you in the high plains where they use them more frequently, often it's 3 applications to really consistently, statistically show a yield difference. Bacterial blight is frankly tough to manage. Switching to white mold. So white mold begins the cycle as sclerotia, and so we have a lot of different broadleaf crops that are susceptible to white mold, and if you have an infection, it doesn't matter if it's dry beans or sunflowers or soybeans, they will produce sclerotia. And so this is my hand with a bunch of these black sclerotia. So right now in the season, we've got some snow, we're frozen, there's sclerotia all over the place if you've had white mold. Now they will germinate in the spring when there's water on the soil surface, and the sclerotia produce this little mushroom. It's called an apothecia. It's about the size of an eraser on a pencil. And when you have this, this is going to release the spores into the air. So we're really concerned about wet soils a couple weeks before bloom. That's really where we start to be concerned about apothecia and the ascospores in the air. So what happens when the ascospores gets in the air is a little different than a lot of the other diseases. So something like rust, those spores will directly infect a leaf tissue. This is not the case usually with white mold. White mold, that spore is kind of the weak part. And what it needs is a flower tissue to start the process. So this is an image of a sunflower. Sunflowers are easier to take pictures of, very visual. But what had happened here is that there was spores in the air. It landed on a floret during a moist weather pattern, and it started digesting that floret, that flower. And from there, wherever was touching green tissue, it would spread. And you can see this thing spread in the sunflower leaf, even in concentric rings. So that's why these plants, it doesn't matter if it's soybean or dry bean or canola, why they become very susceptible during bloom. And I would emphasize that every broadleaf crop we grow is susceptible. They're not all equally susceptible, but they're all susceptible to white mold. So of course, once you get it in that green tissue, and often in the leaf or the petiole, it'll go right to the stem. And these early infections in particular will cause quite a lot of plant death and yield loss. Plant-to-plant spread is a real thing, and it can be problematic, especially if the beans stay in the field for a long time when it's wet. We do see increased losses from that. I would suggest that this is pretty common in sunflowers, and you can see this whenever you have a sunflower leaf touching an infection that just grows right into the next green tissue. And Michael Wunsch has shown some pretty good data in Carrington talking about plant-to-plant spread, and I'm going to show you how to access some of that. So with timing, favorable conditions are really dependent on bloom stages. And we have done some, Michael in Carrington in particular has led the way in doing some refinement of the timing of fungicides. But in general, it's in the early to mid bloom stages. Fungicide efficacy is, there are fungicides that work. We see rate responses. So if you're putting something on like topsin or T-methyl under disease pressure, there is a difference between 20 and 30 and 40 ounces. So sticking with that middle rate for something like that is important. And there are multiple chemistries that are effective. So we know of topsin and Dura, and there's others out there that are pretty good at managing this if you get the timing on and you don't have a tremendous amount of pressure. Under really high pressure, the fungicides are going to be challenged. Okay, so I'm going to take you to the Carrington website here. So I would just Google Carrington Research Extension Center and then get to the plant pathology tab. So the arrow there on the left-hand column, it's like an index. Go click on plant pathology, and when you're going to get to the page, then you'll see a whole bunch of published PDFs of recent talks. And Michael puts his talks up here, and he's continuing to update this, but they're very informative and they're very well organized. And so we'll look at a few. So he's scrolling down that page a little bit. You can see that there's a lot of optimization things going on. And so optimizing the application timing, the spray droplet size. And then there's a whole series from 2019 in 6 parts looking at white mold management in both soybeans and dry beans with multiple specific updates that have come out of the Carrington REC. So just as an example how to evaluate the results he's showing you, I'm going to take a look at this first part of improving white mold management in dry beans, and that's optimizing fungicide application timing. So I would encourage you to go to these and scroll through. But to make sure you know how to interpret it, I think we'll talk about this for a moment. So in each of these trials, in each of these images that he's got, he's going to give you the critical information about how the trial was run at the bottom. So fungicide applied, the nozzles, spray volume. He's going to give you a series of things, whatever that is, chemical, timing, efficacy, whatever he's testing on the left. And then he's going to give you whatever you're measuring on the right. Okay, so in this case, white mold, sclerosis, and yield. So how you read these colored bars is important. So in this particular case, if you follow me across this one, this is the non-treated control. He's giving you the fungicide timing, the percent bloom, the pod length, and the canopy closure. Of course, with the non-treated, none of that matters really. And then he's measuring white mold, sclerosis, and yield. So for looking first at the white mold level, that bar is 74% of the canopy is diseased. You'll notice right away that bar is dark blue, okay? If you go down, you can see that there's 3 different timings that he's looking at. So the 24th, 26th, and the 28th are the dates, but it's all related to percent bloom and pod length and canopy closure, okay? So as in this particular trial, as the date and it goes on and the canopy closure gets a little tighter and the pod length gets a little longer, you can see that Michael's having better luck managing white mold. So he's optimizing this timing. You'll also notice that those bars are pink, okay? And that's important. So the difference between dark blue and pink is statistical significance. So we always talk about the letters, the LSD letters, you know, the A's, B's, C's, and D's that you see behind the bars. But this color coding is a pretty good way to see if, hey, that was statistically different. And so the non-treated control is going to be blue. If the bars are pink, that was statistically different. If you have something here where you have kind of this lighter blue, there may be statistical difference involved, but it's not different than the non-treated control. And that's what's important here. So I would encourage you to visit some of these. There's a lot of information here, a lot more than we can go over in a short period of time. But each of these is generally set up the same way. So hopefully you can interpret them and it'll help make decisions for your operation. Last thing about soybean cyst nematode, and this is just a reminder for everyone, soybean cyst will cause problems on soybeans and dry edible beans. And pintos and navies are not quite as susceptible as soybeans. Kidneys certainly are. And blacks are the least susceptible of the market classes. So this is a parasitic worm, and if you see it on the roots, you're looking at very small cyst structures, and this is the worm itself, and she's full of eggs. Each of these little cysts has about 200 eggs in it. We've seen damage on dry beans, and this is an image from a kidney bean field in kind of central Minnesota, and I would expect we will see more of this in our production region as SCN spreads. The North Dakota Soybean Council is funding a survey program that growers have used for 7 years now. And the growers can go to the North Dakota County Extension Office, get in bags, take these soil sample bags, they can sample soybean fields, send it into the lab and they get their data back and then we map it. So this is the updated map and you can see these colored dots, colored shapes, they're all real. And when you're hitting yellows and reds, you are very high. There's a lot of SCN. The black circles are negatives and the gray boxes are generally considered inconclusive. They could be real or they could just be a low-level false positive. There's a heat map on the right side of the screen. As you can see, I would just suggest that all the counties here are likely to have SCN. The one thing I would suggest to dry bean growers is if you are in that Pembina, Walsh, or that Devil's Lake area, we are kind of operating blind. There are not a lot of samples from those areas. And so I would strongly suggest that you consider sampling your soybeans if you're growing soybeans as well, or sampling dry beans. A note of just for a little bit more information on that same publication I showed you earlier, there's a lot of information about SCN and there's a specific SCN soil sampling guide that you might consider.